lines. And there are three cases. So case number one is you graph a line, you graph another line, and they intersect. That's what you'll see most of the time, 80% of the time, we'll say. Case two, well, you graph a line, you graph another line. These are parallel. Okay. Parallel means that they never intersect. Never, ever, ever. Case number three is when they overlap. Okay, so this call this overlap.
Mm-hmm.
So in terms of solutions, we'll talk about that in the next line here. In terms of solutions, this has one solution because they intersect at a point. Case two has zero solutions because they never intersect. And overlap has infinite solutions. You have to know all this. You have to say, oh, they intersect, that's one solution. They're parallel, oh, that's no solutions. They overlap, that's infinite solutions.
Mm-hmm.
There are also other words that you might see in this part of the course. Okay.
What are some other words that I'd be seeing?
Independent. Dependent. Consistent.
Mm-hmm.
And inconsistent. Now, the thing that's probably frustrating for you as a student is that like I can't tell you like in what context you will see this.
Yeah.
You just have to know that, hey, there's these three possibilities. Yeah. And you better know all of these. So it won't make sense for a while, but someday it will.
And we can just hopefully speed up that process. So
yeah. So like you want to have this down as notes or look at it later as notes, and then we can actually move to like, well, let's solve some problems and see if they're which of these it is. So I can do that now if you would like. Is that okay?
yeah, let's move on to the problems.
Okay. So do you want to just move right to graphing systems, or do you want to graph some lines first?
Is that like the problem? Which one has like the problems involved with it, where you figure out where it all goes?
Yeah. So like, I don't like any of these to start out. Let me find something that's a little bit easier. Like, and when I say easier, I mean it's more kind of
Makes more sense.
Transparent when you're starting out here. So let me snip in a question. So this is your test question. Sometimes it's good to know where you're going. This is your test question. Zach, you're going to be given a system of equations, and your instructor is going to say solve by graphing. Meaning, don't use another method. Solve by graphing. So that's why you had that. You had some problems there where you're graphing just lines, because it's building up into, okay, now you got to graph two lines. Oh my goodness, right? So to graph, when it's in this form, when it's in y equals mx plus b form, you need the slope. Actually, remember, that might have even been our first lesson this year. The slope is the number in front of x. What is the number in front of x in that first?
-1/2.
-1/2. What is the b value?
-1.
Okay, so you start by graphing the b value. So okay, see I graphed it there at -1.
Move down vertically 1 unit, and then that would be like the slope is the -1/2, right?
Yeah, you go down 1 and right 2, down 1 and right 2, and so on. Now, in truth, you only need 2 points for a line. Okay, but if your instructor says, hey, I want 5 points, then do 5 points, but you only need 2 points for a line.
All right. I also have a question.
Of course.
Interrupt me. The slope with a fraction.
Say that one more time.
So to know like the slope for the fraction, I look at the top for going up or down and then the bottom for it going to the right.
Yeah, so you always put that negative with the top.
Mhm.
Right. So let me back up here. So slope is rise over run. So when you have a slope like this, your rise though is down
Mhm.
one because
To the
it
right.
rise means really encoded in this means up or down.
Yeah.
And you always go right on the bottom.
Okay, so then if it was like positive 3/4, it would go up 3 into the right 4.
Yes.
Okay, cool.
Yes.
I got that now.
Okay. So the second equation here, we got to find the slope and the b value. What's the slope? What's the b value of the second equation?
Um,
Slope is the number in front of x.
1/4
And the b
and
value is
-4.
-4. So you always start at the b value. So you start there at -4, yay. And then we go up one,
Up
right?
1.
Slope is rise over run. So we go, this time we go up one, and then we go right 4.
All right. And then so you put up
Yeah.
1. So then wait, so why am I putting it all the way down there?
I'm just adding another point. You really need this point, these two.
Okay, so wouldn't I place it as like where I'm just a little confused on why like the second part of the graph is down there.
Okay,
'Cause
so that's b value of
oh,
-4.
-4 and then
Yes.
okay, never mind.
Up one, right 4.
All right, never mind. That makes sense. I don't know why I was going all weird about that.
All right, so a couple things here that are important because you're in a classroom. One is you need to use a ruler.
Mhm.
You can use, students use their IDs. I mean, that's not the right tool. You're a car guy. If you need a socket wrench, use that. You don't use a hammer. Like use a
Yeah.
ruler if you can. The second thing is to put arrows at the end
Yeah, show they go on.
forever. Okay. And three is like if it truly intersects at that point, like make
Leave it.
sure it actually intersects where you think it's supposed to.
Mhm.
Like don't get it's like it's so it's inside the box if it's really on the edge, which is why you want to use a ruler.
Yeah.
And if we're in person, I would pull out graph paper and I would show you these things. I mean, we're just not doing that anymore.
Yeah.
But the point is you might be graded on that. Okay, so your solution here is 4, -3. When your instructor says solve by graphing, they are looking for this that I boxed in, and they're looking for this graph that's correctly done. They might even want you to label some points.
Mhm.
Not sure. You may want to ask that question.
On the test, I'll ask her.
Yeah.
For sure. I still do it either way, just play it safe.
Great.
Yeah, like I label all that. Rather play it safe than sorry.
Yeah. So let me give you another problem here to look at. And if you're comfortable, I would love for you to do this on your own just to see if you got it. If you don't have graph paper, that's okay. Just try to make it as neat as you can.
Mhm.
But it would be good for you to try, this next problem on your own if you're willing.
Yeah, I'll try. Okay.
Find the slope, find the b value, find the slope, find the b value.
Yeah, I guess it's nice for horizontally, you can just follow the line.
Yes.
So I'd be making it be 4/1, correct?
The m is 4/1
Okay.
and the b is 3. And you need your slope to be a fraction. So this means you're going up 4 And you're always going right. Always, always, always. No exceptions there.
Yeah. Yeah, something that was a little surprising. It's not that my teacher the other day said the graph would go to the left.
Yeah, we would, it's like you always read left to right. You always graph,
Yeah,
this way.
that's
That's
one of the
just the way it
things.
goes.
Two, and then minus one, so you'd be going down one to the right. All right. It intersects with each other.
What is the point of intersection?
The point of intersection is okay. Here, wait. Let me look at that again. Sorry. Negative. Shoot. Yeah, I guess it helps if you have graph paper for this.
Yeah, like I'm gonna do it here, but I want to just get a number here ahead of time. But if you don't have it, that's okay.
Yeah, I don't have that.
Okay, so I'm gonna start at 3,
Mhm.
and then I'm gonna go up 4 over 1. So do you see a problem here that I really can't graph that point?
Yeah, it's just not on there. The graph doesn't go up that high.
All right.
And then that one
So-
goes down to,
Yeah, so you actually got, you have to do this.
so
So you get these are the points you graph for that first one.
yeah. So how do you know where the third one goes? Like that, or is that
Give me just a moment here.
all right?
All right, I'm back. So I guess what I was trying to say here is that normally, let me just get rid of this. Like you graph this first point and you would just go up 4 and right 1, but you can't because it's not on the graph.
Uh-huh.
Like you could try to be like, yeah, it's kind of there, but I wouldn't do that. So sometimes it's
Oh,
not
so
that,
then that one is the same exact thing.
yeah, it's like going backwards. You're like, okay, I
Okay,
got
all right.
where do I put the point? So when I go up 4 over 1, I get back to this one.
So then you can really make your graphs like really, really accurate with that.
Yes, yes,
And then that's how you figure out the point. Okay.
and depending on your instructor, you could get a really tough intersection point or not.
Yeah.
So there's -2, and then this time your slope is -1. -1 over 1. So that means you're going down 1, right 1,
Down one, right one. All
down
right.
one, right 1. I mean, and I don't know how many you need to graph here because I mean I've said it a couple times. You only need 2 points,
Mhm.
but if you feel compelled to do more, that's fine.
Yeah.
If you use a ruler, you only need 2. If you're freehanding it like I am, more the better.
Yeah.
So I was asking you for this intersection point. Where do they intersect? Because that's super critical here. Super critical that you can identify that point.
So then the point they intersect at is -1 and -1.
Very good. Very good. Okay. Now, have we used Desmos before?
Yeah, we have once or twice.
Okay. So let's look at another problem here, but I'm going to use Desmos to solve it.
All right.
And I'd like you to,
Do
since
the
you said you don't have
long
graph paper, maybe we can have you do one that way just to get a feel for in this. And then we'll move on to like a related topic for this
Mhm.
class. So did we do that one? Which ones do we do here? Okay, so we're going to graph. We're going to graph these two equations.
All
All right.
right.
So I'm gonna go over to my Desmos. You don't have to copy these down. If you want to, you can follow along, or you can open up Desmos yourself, the
Oh,
graphing
yeah.
calculator here. All right, so if you're seeing my screen, you see that first line there that's
Mhm.
drawn. So that's got a b value of 3. Okay.
Yeah, and then it
Okay.
goes
And then what's the
down
slope?
5 into the right by 3.
Okay. So if it goes down 5 and right 3, that's going to be what do we say here? -2 comma, oops, 3 -2. Let me get that point. 3 comma -2. Do you see that that point is also on the line along with that one? Like you just said, down 5, right 2.
Yes.
That's great. Now we're going to graph the other line, y equals 1/3. Now, after you put the 1/3, you got to put the x to the right of it, not underneath. Like if you put it down here, oops, get rid of that. If you put it down here, that's wrong. It's got to go just to the right of it.
Just to the
Minus
right.
3. Yep, -3. This one, it actually already graphed the intersection point, so that wasn't
Okay.
intended.
Yeah,
But if you,
just
but when you want to find it, you just go ahead and click on it, and it'll tell you
show
where
you
it
up.
is.
All right.
Okay, so let's just say I asked you to graph these on your own. Do you feel like you could do that now?
Yeah, I feel like I could do that now. The thing that was
Okay,
confusing me was the fraction to it.
yes.
Didn't realize how simple that was.
Okay, so let me have you graph the following. I'm gonna go back to our screen that we've been sharing with all the notes in it. I'm gonna ask you to graph something on your own. Let me know if you need that link to Desmos, but I want you to graph 6 here. Just enter those two equations and
All
let me
right.
know what you see. Where do they intersect?
Um, oh shoot, here, wait. Would you mind putting that link in the chat? I just, instead of clicking on the tab, I
Sure,
accidentally clicked X.
sure. So give me just a moment here to get back to that. There's the chat.
All right, thank you.
There it is. Got it.
Perfect. All right. -2. This might just take a little moment. I'm not the best with this one.
That's okay. Take your time. This is an important skill to be able to go use a tool that you find on the web.
Yeah, I agree with that. All right. Two. And then do I just press enter for another row?
Yes, or you can click.
All right, thank you. And then in the other row, you put in the other graph, correct?
That's right.
Okay.
The other
Well,
equation.
other equation,
Yes.
So then this one is a parallel graph, correct?
Do they intersect?
They do not intersect.
They do not intersect. You could zoom out forever, right? And you would never, ever, ever
See them intersect.
see them intersect here. So why is that? Well, let's look at the two equations up here. What is the slope of the first equation?
2.
-2. What is
My
the
bad.
b? What is the b? Yeah, no problem. B. What is the b
Positive
value?
2.
+2. Okay. What is the slope of the second equation?
-2.
What is the b value of the second equation?
-2 again.
So what matters is the slope. This means parallel. Same b value, don't care, doesn't mean anything. If the slopes are the same though, they are parallel.
If the slopes are the same, therefore they are parallel.
There's a little bit more to that, like they have to have different b values, but just let's go with that for now. So what I want you to do is I want you to change this in the second equation. See how that's a negative in front? Just make it a plus by deleting it and tell me the intersection of the two equations. Give me that intersection point.
It would be 0, 0.
It is not 0, 0. That just you're deleting the negative, so it'll just be 2x minus 2 this time.
That's weird because I actually have 0. I have that, and it's a 0, 0.
Okay, let me snip in what I have, and you can compare to your screen.
2x minus, yeah, that's odd.
Okay. So this is, I'm snipping it in now. Does your equations look like these? Minus 2x plus 2, and then 2x minus 2.
Yeah, exactly that.
Okay, so like I see them intersecting at 1, 0, not 0, 0.
All right, and yours is correct, right?
Yes.
All
So,
right.
so there's something going on here. Like maybe yours doesn't look like this.
No, it's kind of funny because like it's just like exactly that.
Okay.
I don't know why it's doing that.
All right. Well, let's not dwell on that because it doesn't really matter.
Yeah.
So I am still sharing my screen, and we're gonna move to systems of equations where they're not as nice as these. Like the ones I saw on your homework or your review that you sent by email, they're not in the nice form that we want them in. Okay, so what does Matthew mean by that? Let's look at number 3 in your thing there. So here's number 3. So again, it would say solve the system by graphing.
Solve the system by graph.
Like they will tell you, they will say thou shall graph. Okay. Now, now I'm going to do this. This is you're not going to do this, but I want you to see how this tool works. If I go back to Desmos, okay, and I just literally type in what they give you, minus 3x plus y equals 8, and minus x plus y equals -2. Now, if your window's kind of messed up, you can hit this home button over here. Right? And I can't quite see it, so I just drag. And there's,
not there.
and there's your solution, right? But you're not going to be able to do that because you're not going to have Desmos on your exam. So we got to be able to do this another way. So let's go back to our workspace and figure out how to do it another way. So if possible, you want to convert these both to slope-intercept form. And you do that by, quote, solving for y.
Y equals mx plus b.
Yes. So take this first equation and solve it for y.
Equals 3x plus 8.
So now, what is the slope? What is the b value?
The slope is 3/1, and the b value is 8.
Right. Okay. Now, to graph that, so this doesn't work out well when but we'll just keep going here. Let me grab the next one. So minus x plus y equals -2. Y equals x minus 2. And what's the slope?
The slope would be just 1/1.
1/1, and the b value is
-2.
Great. So now you can imagine graphing these if you had the right graph paper to do this. Now I don't really like the one they gave you, but let me grab a blank one here. Here we go. So let's try graphing it on here. So the first one has a b value of 8. So you're going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. There's your b value. Slope of 3/1. So you see how there's a problem there? Like I'm off the grid.
Yeah.
So to do this correctly, I got to go backwards. I got to go backwards and find that point where if I go up 3/1, I get to that point. And then like I just keep going backwards here. You're not graphing left. You're just finding the previous point. We want to use the right language here. Okay. And I don't know how many of these points to graph. You know, if I had a ruler, if I had a really good ruler here, I would just, you know, connect those. But you see, the smaller the grids, the harder it is to do. And actually the solution is way down here. So actually I do need to kind of be a little bit more nice about that. So now we go to the next one. The b value is -2. Slope of 1/1. So that's up 1/1, up 1/1, up 1/1. That's great, but now we got to kind of back it off into, you know, like there's the intersection point. I'm sure that's hard to see on your side. We already found, I think it was -5, -7 for that.
All right.
But the point is that you go ahead. Sorry. Go ahead.
So there always has to be like those two different problems in order to find a graph like that.
Yeah, you're going to be given two equations, and in this case, you solve for y because that's like the way one way to graph. It's not the only way, but
Do
it's
you ever
one
have
way.
like two equations for something like this?
Yes, but they would only either intersect in one point or other things could happen, which we're not going to talk about here.
Yeah. Okay. Do you think
All right.
I'd be seeing that like anytime soon or?
No, not in this class. In another
Okay.
class for sure. Yeah. Why did they do this? Why did they do this? Okay, so let me grab question 4.
All right.
And you'll notice that one of them, let me snip this in, one of them is already solved for y. So that's nice. The second one there. Second one, you can get the slope and the b value right away.
All right. So then that would be.
So the slope of the first one is, or second one is -1/2, and the b value is 2.
Mhm.
For the first one,
Wait, would it be -2/1 instead?
for which one?
The first one.
For the first one, you're gonna have to solve it for y.
Oh, sorry. I thought you were doing the first one.
No.
Yes. Okay. So for the first one, it would be the m equals -2/1 and
What's your equation though? What, like, solve this for y? Y equals what?
y equals oh, we're getting just y. So then that would be -x plus 2.
Okay, so you're missing some steps here. So it's 2y equals -x plus 4, and then you divide by 2. You
Oh, and
divide
then
everything by 2. So it's -1/2 x plus 2.
Okay. I'm a little bit more confused on that one. So this is different than what we've just been doing.
No, I mean, so look at that first equation. X plus 2y equals 4. You need to solve for y. The easiest way to graph something is if you solve it for y in your situation. Let's not do anything more advanced than that. So I'm asking you to solve this equation for y on the left. How would you do that?
I'd get the x over.
So
So
2y equals -x plus 4.
mhm. So then I'd multiply this by 2 or divide it by 2.
The 2 is multiplying the y, so you undo multiplication with division.
So then okay, so then that would be -1/2 and +2 or would
Yes,
okay.
right. You're doing it to both. Okay. So now
Okay,
what is the slope?
the number like the number before the y just threw me off there.
Yeah. What is the slope and what is the b value?
The slope is -1/2 and the b value is +2.
Yes. How does that compare to the previous one?
The other one also is -1/2 and +2.
Yeah. So these are actually the same line when you graph them.
So
Because
then
they have,
that would make it
so the b is 2, and then you graph, the slope here.
so down 1 and 2 to the right.
Yep.
And then you'd have to make 2 lines since they're both there.
You just sort of show that. That's where the words are important, that they're the same line,
Yeah.
which we
So
never
that would-
used up above. We used different words than that, but that's kind of the right way to think.
So then what would that line be called again, like this problem?
Let's go back and look here just to use all the right words. So this is the case where they overlap.
So then overlap infinite solutions.
Infinite solutions, and they're dependent.
All right. I'm gonna make that a flashcard later.
Great. Okay, so the next kind of questions that I'm seeing on your worksheet here is like, well, what happens if I give you kind of x equals or y equals? So just a brief review here before we do that. If I give you the equation y equals a number, This is always a horizontal line. If I tell you x equals a number, this is always a vertical line. However you want to learn this, remember this, like you just have to get this embedded.
All right, y horizontal, x vertical. All right, I think I got that down in my brain.
Okay, good. So
I
let's
definitely
look.
did not a month ago, but now I definitely do.
Yeah, it comes back over and over again. So you get, more chances here. So let's say I wanted you to graph this system. Okay,
Mhm.
graph this system. So what is x equals -2?
It's just going down -2.
What kind of line is it?
That would be a horizontal line because
X
there's
equal
no other number.
x equals 2 is a vertical line.
Did I say horizontal?
You did. Maybe you meant vertical. Maybe you meant so it's a vertical line. So it looks like this. It looks like this. Yeah, it goes up and down. Okay, that's x equals -2. This other one, my recommendation for you would be to probably always to just solve for y. We can do some other things, but that's probably the best approach for now.
So x would be, it would be like -2 and 0, right?
Sure, if you want to put that point on there, you can. Yes, that's -2,
Okay.
0.
So then that one, we'd have to make it -2y equals 3 equals -3x minus 18.
Yes.
And then you divide by -2, which would give you +1.5.
3 halves. You don't want to say
So
one and
I
a
would
half because
not
that,
write it like that. Okay,
yeah.
true, right? Because we have to make it rise over run. So then the other one would be +9. So then M is 3 halves, and then B is +9.
Yes, that's right. So to graph this one, right, I don't have enough room. Like I got to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my 9. Oops, I mean, not in the right spot here. So there's your 9. I went up 9 all the way at the top there. I'm just talking about 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the slope is 3 halves.
Mhm.
Okay. That means you're going up 3, which I can do because I got grid paper here. So I can do that over 2, but that doesn't help. Like we need to go in the other direction. Like, so where do we go up 3 to get that? It looks like right there.
Yeah. So then
So like this is
yeah.
your equation. We want to find that intersection point. It just so happens to be right there is where they intersect.
So then that would be -3 and
-2, and then up 1, 2, 3, 4, 5, 6.
okay, sweet.
So what I would like you to do is I'd like you to go into Desmos and I would like you to graph these on your own right now and just confirm that you actually get the same answer.
Okay.
So literally you type in x equals -2, enter 3x minus 2y equals -18.
X.
It's very important that you see it, believe it,
and see how it all works. All right. Do you know? Also, I have a question. Do you know the settings for Zoom where if I touch something in the background, it won't get rid of the video? Like, Desmos will just always go away.
You want to change the view to not be full screen when you're kind of moving between windows, if that makes sense.
Mhm.
Okay,
It's
I mean, I'm not seeing your video. I'm not seeing your screen.
X.
Just to be clear, like you are doing all that on your own. I'm not. You're not co-host. If you're a co-host, you could share your screen, but
Yeah.
we don't need to do that tonight.
So then, I might have a question once I finish typing this out.
Sure. So what I'm going to do is graph it on my side as well, and then you can just compare. I'll snip in a picture and you can compare, see if that's what you have, because it shouldn't be any different when we do this.
I think I'm ready for the picture.
Okay, let me go ahead and just zoom out here a little bit. Yours will be different color than mine. but
Yeah.
the intersection point should be exactly the same. That's what matters here. So I'm snipping that in. Okay.
Man, I don't know what I'm getting wrong here. I have the same exact thing, but it's different. It still says it's like connecting it 0, it's -2 and 12 and 6 and 0 or something, but it looks like it's on the 0, 0 for some reason.
Yeah.
Oh,
I'm not sure here. Let me go over to Desmos, and I guess maybe you can follow along here.
all right. Yeah, maybe there's.
Okay, so just
Yeah.
close out everything, hit the home button. So you should have nothing over here. You should see exactly what I see, and then we'll go through this one at a time.
Yeah, I'm just gonna reopen Desmos.
Okay.
And maybe, I don't know, maybe like the page somehow glitched or something, but it's pretty weird. All right. Home,
Just,
everything's untouched.
okay, so type in x equals -2.
X equals -2.
Okay, and
Okay, well,
what
now
color is your line?
it's red.
Okay, so your line is red. All right. Does your
Yeah,
line,
now it looks like yours. I
okay.
think maybe it was just bugged from like maybe through the link or something.
All right,
And
so
then the
now
other is 3x minus 2y minus 2y equals
-18.
-18 and
What color is your line?
blue, and it looks exactly like yours.
Okay, now if you click right there where they overlap, does it
-6.
great,
Okay,
excellent.
sweet. That was weird, but
That's okay. That's you're learning a valuable skill here to be able to go in and use a tool like this. Like because if I'm not there to help you, you got to go find some help, and this is something you know how to use.
yeah.
So what I want you to do is use Desmos, and I want you to solve number 5. Number 5 here. So I'm going to snip that in.
Number 5.
I want you to use Desmos, and all I want to know, like imagine I'm grading this. This is how all I'm checking for is the ordered pair you put in this box.
All right. Desmos. Delete. X plus 3y. 15. X minus 3y. X minus 3y. Here, wait. I need to restart this one. I realized I didn't set it up right.
Okay.
3y minus 3. Okay, here, wait a second. 3y equals minus x minus 15. And then divide by 3.
Oh, just type this into Desmos. You don't have to make any changes to this.
Oh, so I can just still type it as 3y equals, I mean, x.
Yes, and that's the power of this.
Okay, cool. I was like, wait a second, I'm missing a step here. All right, x plus 3y equals -15. Next row. Y equals -7. Huh. Okay. Is it? I don't think it's 0.5. Something
Nope.
weird with this again. I'm gonna
Yeah.
I'm gonna copy and paste this so I don't have to like type it for the 3rd time. Just relaunch Desmos because I don't know why it's not working. Desmos, there we go.
Okay, well we can do it
Now
together
it's
here.
working.
Okay, do you have an answer for me?
Why? equals minus 7. Okay, I don't know why it's not working. Oh, wait, it is. Okay, wait. Okay, the meeting point is -36 and -7.
Nope. Okay, so let me, so reload Desmos, and we'll just do this together. This is one of the limitations of doing it virtually, is I really wish I could be right there showing you how to do this, but let me new share this, and you can get this. This is not beyond your ability to do. So
Yeah,
let me know, hit the home button, make sure you have exactly what I have here.
yeah,
Okay,
exactly.
x plus 3y equals -15.
Hmm.
What color is your graph whenever you get that? So we can match it up here.
It's blue.
Blue. Okay. Do you have exactly what I have on my screen?
Yeah.
Okay. Now enter, or go to the next line, right?
Mhm.
Y equals -7. What color is your graph?
Mine is red.
Great. Now I don't see it on my graph. Do you see, like, and the reason is I got to zoom out. So zoom out.
That's what I had to do.
Okay. And then do you have this point here where they intersect?
It's no, they're not there for intersection.
Did you have to click on it? Did you click on that point?
Wait. Why? I'm just retyping it. So then x equals x plus 3y equals 15.
-15.
-15. X plus 3y equals -15. Y equals -7. Okay, well, I don't know what's up, but now it's doing it. So I got it now.
Great.
6, 7.
Great. You are going to take more math classes, and at some point you may have to enter like numbers into different online homework systems. So this is a valuable skill for that.
Yeah.
Don't take too much away. I mean, I like Desmos. I don't know if they got anything like related to cars, but maybe they do. They got a lot of applets out there. Just this is a worthwhile tool to learn. Like I would never try to have you learn something that wasn't going to be useful to you over and over again. This is something worth looking at.
Yeah, and so this can always be used for a graph.
Yeah. Okay. Is there anything else? We've got like 1 or 2 minutes left. Oops. Let me go new share back here. Is there anything else? I guess let's just look one more time at that table here again. This is your cliff notes. Your main takeaway from today is when you're graphing two lines, the first and hopefully the most often possibility is that they just intersect. Intersecting is great. You have one solution. That's like what you want. The other two are exceptions, meaning they don't happen as often, but you probably see them on the test. So case 2 is for parallel lines. They never intersect. You're driving now. You're going down Speedway. Your dad's going down Broadway. You guys are never going to hit each other. Okay. Or you're in parallel lanes. You're not going to hit each other. There are no solutions. No solutions. Overlapping is the bit kind of the weirdest, but it does happen. They overlap everywhere. So that's why there's infinite solutions. Every single point is a solution because they hit each other. Boom, 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 right on top of one another. And then there's other words for now, they just go along with it. What your instructor may ask is like, is the system consistent or inconsistent? And you're supposed to figure out whether they intersect or don't intersect.
All right.
But you'll see that later on.
Okay, sweet. All right, this is all making sense to me now.
Excellent. So that does take us to the end of our lesson today. Thanks so much for scheduling. I'll see you next time whenever those, and I'll send you the notes here shortly. Have a great night.
All right, thank you. You too.
You're welcome.
Man.
Bye now.
See ya.